Hello again, we're here at Junkyard Studios. I'm sure you've noticed in a lot of my videos, if you've watched them, that I've been testing almost all of my gear through this Farfisa. And it's a little hairy. It's got a little noise. I told the story about this amp through my first introduction video. You can check that out if you like. I nursed it back to health, and it's been a while since I've opened it up, and I can't remember exactly everything I did to it. So we're going to pull it down today and take a look at it and see if there's anything I can maybe improve on with that noise. So here's the rare back view of the Farfisa. These amps are pretty uncommon, I'd say. This is the only one I've ever run across other than online. And you see my coffee cup there. Usually that's sacrilege. Like, people would be punished for this, but they made these little cups. There are these little plastic cups on the top here so that you could stack, because the bottom has a similar shaped cup. So you could stack 2 or 3 amplifiers after a back transplant and rock out. On my particular model, somebody put their 2 cents in. It's actually only 1 cent, so it probably wasn't very good advice. And it's got this neato top grill for venting, which is also conveniently foot-long sub-shaped and will heat your lunch. So, let's open up the back and get a closer look. Here we have the back of the amplifier opened up for you. They give us this convenient little cubby for power cable, and it has 2 speaker outputs with a weird switching configuration on the front, which says 1 box, 2 box, which I think was just so that you could run a couple different cabinets in a different configuration, I guess. It also conveniently will hold a sandwich, just like the top, so you can store it there and then heat it on the given pad. Obviously, I'm kidding with that. Here's the spring reverb with is it German? That'd be odd, because this is an Italian-made amp, and it says Chicago Musical Instrument on the back. I wish they'd make up their mind. They made it, the craftsmanship's actually pretty good. They made a little spot for it to slide into. That's pretty nice. Usually these things are just like screwed into the actual frame there. They even gave us little rubber supports and a base for it to rest on, so it can kind of, it's a little shock proof, sort of. And here, see, we have another grill down here. That one's less effective at cooking your sandwich. And here are the 4 EL34s. Ha! And I believe those are 2 12AX7s on that preamp card up there. The one thing that I did not do with this amplifier, and I don't have a means to as of right now, is I did not do the tube bias. That could be part of the problem. It might be running too hot. It definitely, I wish I had a temperature probe so I could show you. It definitely gets really warm on that sandwich vent. So that could be what we're hearing, that fuzz, I'm guessing, because I remember now I've replaced every electrolytic cap on the front panel and in that amplifier. So this is brand new components, and it wasn't that long ago. It couldn't have been more than 4 or 5 years. Caps shouldn't fail that quick. So I've watched a couple of tutorials about making a bias probe, and I think I have all the parts, so maybe I'll give that a whack and we'll take a look at the bias on this amplifier. You'll notice on the reverb tank that I put these really nice Switchcraft RCA plugs. I didn't really have a problem. I hate those cheapy ones that come with all these amplifiers that don't have any proper casing to them, so I replaced it. I think it looks really nice, and I believe I replaced one or two of these wires because they were pretty chopped up. When I was putting this reverb tank back, one thing I saw, I'll get you in here, is there is not a lot of clearance here between that plug. You saw that wire move because it's pressed up against that power amp chest. They really didn't leave me a whole lot of room. I can't flip the tank either because those leads are too short. Now, it's probably nothing, but I wonder if that could be contributing to the noise, because this, I believe, is a shielded cable, but it's not of the best quality. The shield is probably a single wrap all the way around. It's not braided. It leaves a lot of room for transmitted noise to get in there. I'd almost like to, before we do the bias, I'd like to fire this up and move the reverb tank and see if that changes the noise we're picking up. Like I said, it's probably nothing, but it's always worth investigating. One reason I'm suspicious of that reverb tank is my Lab Series L9. These are solid state. They're pretty great. They used to be pretty inexpensive, and nobody was really grabbing them. I don't know what happened over the past 5 or 6 years, but I guess people caught on because they're getting expensive. Back to the point, my reverb tank on this amplifier is the noise. And I haven't investigated that. I just know that if I turn the reverb completely off, the noise goes away. And that's what prompted me to go through all my lighting fixtures and everything, which were also a problem, but it wasn't as big of a problem as this. So I was playing in a band at the time, and during the quiet moments, my amp would be over there screaming. It took me a while to find it, and one day I just turned the reverb off and it went away. Like, oh, thank God. Well, there's something going on there, and it's either in the amp can or it's down in the reverb tank. If we have enough time with this video, I'll poke around in there and we'll see what we come up with. But because of that makes me think that this other amp, maybe that reverb tank is too close to the power amplifier. Okay, so we've set up a test to kind of diagnose this noise issue we're having. I'm hoping you can hear that. There's a little bit of hiss. It's really not that bad. Before I get too far, I wanted to show everyone in my little amp book. I have the schematic and this 2-box schematic here. It's right here, and it's basically switching between series parallel. It also has a 27 ohm 20 watt ceramic resistor here, which I believe they're using as a kind of a dummy load, sort of, to protect you from destroying your amplifier with that weird setup. Getting a little closer, you can hear that, and it actually, way down in there, if you listen, let me see if I can turn this up without destroying your ears. It sounds like radio station chatter. That is super loud. kind of hear the radio station getting picked up back there. I'm going to turn that back down, otherwise we will probably die from it. So this amp, if it's anything, is loud. So that right there tells me this little reverb experiment probably isn't going to work. But it's fun to try. And we're already in it, so. I don't know how EL34s are supposed to look. That kind of looks bright to me, but that doesn't mean that it's wrong. That could just be how those light up. We won't know until the bias. So we're going to move the reverb tank. And that really made no difference at all. So that connector bumping up against the power amp probably really isn't our issue. Some sort of shielding setup or some sort of capacitor placement by the input output of the power. Something along those lines needs to be done to probably buck out that radio station we're picking up, and it could be, it might not be effective either. That radio station might just be pumping out so much signal that it's just going to go through a lot of our attempts. So I don't actually think it's this amplifier. I mean, it's obviously this amplifier, but I think there's a shielding or a grounding. It's probably not grounding. It's more of a shielding issue. I don't think the amp is the problem. And now the lights are off because we know how bad of an issue that is in my personal studio. And that made almost no difference at the amplifier. It's still got a little bit of fuzz. So it's not the lights, which I honestly thought that was contributing to it. Usually that's the problem. We're picking up radio station bleed from somewhere. Okay, so I did a little experiment. I put some duct flashing on here. It's basically aluminum foil tape. And this is what I use for shielding all of my guitars. It works really well. Some people argue about the benefits of copper foil, and I've never tried it, so I'd almost like to try the copper foil someday and maybe get some video on that, but I don't have any right now, and we probably won't be able to get a hold of any for a little while. What I do have is this giant roll of aluminum duct flashing, and I did a test strip here to see if it stuck to this cabinet really well. It does. This is a lot smaller than our Leslie build. If you'd like to see our Leslie build, check out that video. One of the things that I was thinking about with that Leslie was shielding it somehow, but that's, like I said, that's a little ridiculous. That Leslie is huge. This amplifier is much smaller, and I probably have enough to do the job. So we might attempt that. That's one of the options that we have. The concept of this is explained in a lot of different shielding videos, but I thought with this stuff, there's a particular precaution you need to keep in mind, because if you just band another piece over the top of that like that, it's not going to make a good connection, because there's a sticky back adhesive underneath this paper in between the metal sheets. And I think that's what a lot of people don't like, why they don't like using this. But if you take another sheet and you fold it over on itself, maybe just a corner, that's usually what I do, is just a corner, that's probably enough. Put that to the sticky back adhesive, and then take that piece and adhere it here and then put another piece over the top of it, you have your connectivity that you need for a shield. And you can continue to do that as you lay these strips all the way through, checking your work with a multimeter. If you do that and you connect to a good grounding point, your shielding should work. I've also heard, when I talk to some people about shielding my amplifiers, because I have done this before, a lot of questions came up, like, why would you do that? Is it going to make a difference? And in the two that I did, I think it really did make a difference. If you think about it, this whole cabinet and most combos and any other head that you're going to get, this is all wood. There's an amp chassis here in this particular model, but there's nothing covering it under here. I could put my finger right into the circuit underneath that. There's a vent, which is metal, but that's also going right into the wood. That's not giving us any protection. So if shielding works on your guitar and your guitar signal is very low, it would probably work maybe on your amplifier as well. There's certainly nothing stopping radio transmission from coming in here. I think there's potentially a couple other options with capacitor placement that might be a little more effective. So we're going to do a little more research and see how that goes. For experiment's sake, I'm going to try maybe shielding at least a portion of this amp right where the spring reverb is coming in, and see if that reduces any of the noise. And then I have other amps that we're experiencing noise issues with, so maybe with those I'll try something different, like a capacitor placement, and kind of give you an inside look at both options. One thing I wanted to show you is I've put 2 bands of this aluminum tape. Over here I folded the corner, and when you do this, you want to make sure this is adhered really well. You want to press this down real flat. You want it to become part of the surface. I also made this little diamond in there is folded over as well, and with my meter set to continuity, so I'd like to take a moment and talk about meters. While I was testing continuity on my little shielding strip here, I've had this meter for a while, and it works on most functions pretty well, but what I've found the continuity to be unsatisfactory. It really doesn't do a good job indicating continuity. It'll probably work now. Barely, right? You hear that? Sounds like there isn't continuity. I mean, we have an ohms reading. That's good. But I'm moving this all over the place along this strip, and I got to really try to get that speaker in there to work. That would suggest that we have a continuity issue, right? Wrong. I mean, in normal circumstances, sure. I got this meter, which I use for continuity. I trust this one a lot more, and I'll show you why. Going down that same continuity strip, of course somehow that got magically tangled, because that's what cables do. When you leave them alone too long, they coil themselves around things. I'll take these down that same strip, and it's much better. We kind of lose it in here, so that's probably not so good. Which, here's the problem right here. I fold it over that corner and that connects these two, but there's nothing here connecting those two. So let's do another one of these down here, and let's see if that changes those meter readings. I personally know that as far as the continuity on this one, it's not my favorite. I don't like following it. This one is way better at signaling continuity, and I don't even know that this is more expensive. It is a top brand, but mine was thrown away, and I thought there was something wrong with it, and I can't find anything wrong with it. But if I was given the option, I'd probably just get another one of these again. In my experience, I think it's more accurate than that model. I put that same connecting piece down here that I did over here. So here's the meter I don't 100% trust. It worked pretty good in there, but from the other meter, I know I have continuity over here. That's right there. See, now it stopped again, even on parts. There, it came back. Even on parts that it had previously tested and said were good, it suddenly lost continuity. I like to hear that beep because I can't always see my meter. So if that function doesn't work so well, it kind of screws up my flow. As you can see, the meter I trust more, except for there, does that a whole lot less. It's a lot more efficient. I just wanted to point that out. There's a reason that I have multiple tools. I really should just have one meter that I trust 100%, which I kind of do. It's this guy, but it's nice to have multiple sets of tools to verify your tools with, which it's getting kind of ridiculous. You're like, oh man, now I need tools for my tools. You kind of do sometimes. It gets that way if you want to get into this kind of stuff. When I got this amplifier, I really didn't open up the reverb tank too much. I just kind of plugged it in, slid it into the back of the amp, and then made sure it worked, because I had circuit issues with that reverb. And I'll show you the circuit a little later in the video. But you can see there's some pretty sad looking strips of what used to be foam there to kind of dampen those springs. Well, those are dried, crumbled, and no longer doing anything. I can put new strips in there. That's probably just some like some window foam, the stuff you'd get at the hardware store and put in your door frame and things like that. But to be honest, I didn't notice that the springs were all that crazy. It seemed pretty tamed to me, so I don't feel I need to muffle it. I'll probably just remove those for now. Maybe if we figure something out with quieting this down, the reverb does need them, I'll put them back in. But for right now, I think we're gonna leave them out, and we're gonna try and shield just this reverb tank and see if that changes anything. I think it might be acting as an antenna, picking up that radio station. Part of the reason I don't want to tame those reverb springs on that Farfisa amplifier is I already have this little reverberation amplifier that I did some mods to many years ago, and it's pretty muffled. What I did was, it was two reverb tanks, and I basically sealed them together end to end, like on top of each other, and shielded the unit. And I put some foam in between the springs to keep them from bouncing around and hitting each other. So it's I put a little note, there's some pot issues here that I'm still kind of working out, and I'll have a video on that as well. But outside of those scratchy pots, it's a nice, clean, tame reverb. So if I ever need a clean, tame sound, I'm going here first. I don't want all of my reverbs to be clean and tame, because that'd be kind of boring. I'd have a whole lot of the same thing over and over and over again. So I want to keep a couple of them kind of wild and untamed. I'd say the most important part on any shielding job you do for any instrument is to, as you're going along, verify that you have continuity between your pieces. Every strip that I'm laying down, I fold over a corner so that it has metal-to-metal contact to the other strip that I'm advancing from. Here we have about 3 or 4 strips. And there's continuity all the way across. Not between here yet, because I'm still connecting that, but that's a good, strong continuity signal all the way through. And that tells me that my shielding job is sufficient so far. Another point I'd like to touch on, in particular with this setup, this isn't a typical setup. You won't find this obviously in your combo amps. We've got some specific challenges to this type of cabinet if you're going to shield it. One of the things I'm trying to do is get my shielding to have continuity to these 4 posts where the spring reverb rests, so that I can have continuity all the way to the spring reverb housing. So I think the spring reverb is potentially causing the noise issue more so than the amp or the front panel, but we'll see that later in the video. So one thing you'll have to do is some of these things are coated either in corrosion or from when they were made. You'll have to kind of sand the tops of them down, the flat area that you can, get some of that stuff off of there to get a good test reading. I'm having some trouble getting a good test reading from here. I think that there is continuity, but I can't get a really good one. See, I'm not really getting a good signal. That tells me that something didn't work right, because everywhere else that I'm testing, I'm getting good signal there. And I'm not getting good signal here, which I even folded some of the material over underneath on the head of this screw, and it didn't come through. So I'm going to have to correct that later in my shielding. Pretty much every piece that I'm laying down, I fold over a corner. And again, that's for continuity purposes. That's so that each layer is conductive. Sometimes you gotta test around once or twice. Usually if I gotta poke around once or twice, I put another piece folded over there. I want a good, strong signal all the way through this tape. And that might be an argument for copper tape. Maybe copper tape conducts better and it's easier to tell what kind of work you've done. I don't know. I'll have to get some copper tape and try it out and film the results. On my shielding job, this stud that was holding the reverb tank popped out. No big deal though, because this allows me to reseat it in the wood with some glue, but also tape with my tape underneath the base of the nail, so it makes a better connection in my shield. And I'll even sand these face plates, being careful of the threads here. And that way it's sturdier than it was, because obviously it fell out. It's sturdier and it makes a more secure connection to my shielding. We have the base plate for the spring reverb out, clamped and drying, and we have a majority of the shielding done for the reverb tank. So we're right at the 30-minute mark, and I'm going to take a break until that dries and continue with this and start part 2 of this video. If you enjoy these videos, please like, share, and subscribe. I appreciate you watching them, and I hope that you learned something. The goal of this channel is to bring you along on my own adventures, so that all of us learn something, even if it's the wrong way to do something. So stay tuned for part 2, and we'll see how this shielding job turns out on this amplifier. Thanks, and have a good day.